I do think that the startup is where all the incentives align around hardening technology breakthroughs or scientific breakthroughs into technologies that can be commercialized. I say that because academia has its incentives tied up in novelty, and it's in nobody's, no graduate student's interest to do the next 27 experiments that confirm the thing that we have already published the Nature paper around, right? So sadly, or maybe not sadly, I don't know, the incentives are just not there to get a scientific breakthrough to the point where it is really something that can be the basis of a commercial enterprise. At the same time, commercial R&D has pulled back quite a bit from being able to take something from academia and really do that hardening process themselves. And so startups really are a place where all of that alignment is there.
Welcome to Discovery Engines, a podcast on the people and platforms who are accelerating scientific discovery. I'm your host, Nabil. What if the biggest factor for whether a scientific breakthrough impacts society doesn't just have to do with the science itself, but the enabling structure that enables that science to go from the lab and into the world? Crazy thought, I know, and history is littered with scientists who made an amazing discovery only for it to get consumed by what some might call the valley of death, that space between the aha moment in a lab and the products and services that we use and interact with in the world today. Well, in this episode, I was fortunate to sit down with Hemai Parthasarathy, a neuroscientist who herself has journeyed from lab bench at Johns Hopkins and MIT to scientific communication at organizations such as Nature and PLOS, to enabling scientist founders to get their ideas out into the world through organizations like the Thiel Foundation's Breakout Labs and Google's X, their storied moonshot factory. In my conversation with Hemai, we covered Hemai's journey from neuroscientists at the bench to enabling deep tech startups, how scientific publishing has adapted and transformed to new trends in technology and open science, the founding model and story of the Thiel Foundation's Breakout Labs, the importance of patient capital and the key factors that Hemai has seen enable scientists to build successful startups, what to make of political headwinds and how to factor in how they will impact your own startup, and we'll get a peek into what's next for Hemai, including a role at the Engine, MIT's Center for Tough Tech. If you're interested in how we can enable scientist founders to get their ideas from the lab and into the world, join me in this conversation with Hemai as we explore her career journey into this very question. Let's go. Hemai, welcome to Discovery Engines.
Thank you.
You're very welcome. Well, we met a few months ago at an event that I had hosted, or co-hosted for the MIT alumni group around AI for autonomous materials discovery or science. And in that event, we talked a lot about machine learning models and robotics and so forth. But one piece that was missing, I think, in that conversation was around the organizations and the funding models that help take ideas from the lab and take them out into the world and make them have an impact onto all of us. And so one reason I'm super excited to chat with you is that you have, through your own experience, worked at a bunch of different organizations that were trying to do that in various forms. And I think have some really interesting insights into this question that I'm excited to explore with you. So thank you for being here.
It's my pleasure. Thank you for having me.
Yeah, absolutely. So starting off with your career and experience, you've had a lot of really cool experiences.
Been all over the place.
Yeah.
Yes.
But some of the highlights that stuck out for me. So one is starting off, in your education at Johns Hopkins, where you studied biophysics and Russian. Later got a PhD in neuroscience at MIT. You were senior editor and acting North American editor for Nature. Founding editor of PLOS and managing editor of PLOS Biology, which is, I think, a really interesting organization sort of advocating what seems like more open research. Scientific director of the Thiel Foundation, where you helped create Breakout labs. You led rapid evaluation, the rapid evaluation team at Google X, which is Google's moonshot factory, and you currently serve on the board of a number of different startups. Am I getting that right?
That's absolutely right.
Okay, awesome. So a lot of cool stuff for us to dig into. So maybe starting back from the beginning in your education, like what initially inspired you to study biophysics at Johns Hopkins and then go into neuroscience at MIT?
I mean, honestly, I don't know that I ever thought about being anything other than a scientist. My father was a physicist. It was sort of in my DNA, if you like. And when I got to Johns Hopkins, it was a choice between the rigor of physics and its ability to really answer questions well, and the new frontier of biology, which had all of this open space to it, but it's a very, very complex system to try and tease apart and study. And so I kind of met in the middle and said, let me do a biophysics degree. So I did that, and then in my last year of biophysics, I took a course called Ion Channels in Excitable Membranes, and I fell in love with these molecular motors, these tiny little proteins that could let ions in and out of cells and really control the way cells communicate and function. And of course, no better example of the use of ion channels is the neuron, which led me into neuroscience, which led me to my PhD in neuroscience, and that's the story.
Wow. Okay, so a real deep interest in science,
Yeah.
and that kind of continued to evolve and go deeper. I guess as you were going through the process of just doing the science and kind of scientific discovery, what did you learn about the process of how science actually happens?
I think scientific education, even somewhat through the undergraduate level, is very much, or was very much, didactic about the facts that we know. And so I think everyone goes through this period of really understanding that it is an exploration, and that a lot of what we think we know will turn out to be wrong. And so I think that was, awakening we all have. What I would say is that I didn't expect perhaps the importance, there's tenacity, there's curiosity, there's hard work, there's brain power, but then there's also luck, timing, and mentorship, which I think are so important in the ultimate success that you achieve as a researcher.
Luck, you said timing, and mentorship. Okay, how did that crystallize for you, those three things?
I think just watching my cohort and watching all of us, the questions we chose, the question that we were passionate about, was that something that met with the technology readiness of the moment to solve? Like you can really care about how the brain works and how do we get from neuronal activity to cognition. But if you don't have the technology or the tools to really unlock that, or to ask the questions in a well-posed way, then you're just not going to get as far as somebody, for example, that is riding on the wave of the molecular biology and genetics to answer questions about basic neurobiology. So just watching the way the passion for the questions matched with the readiness of the solutions, and watching how mentors guided students to ask those questions, not just about what they cared about, but what could be answered. I think just the range of what people achieved reflected a lot of that.
Was there a specific mentor that had an impact on you, or sort of that modeled that behavior for you?
I've been lucky to have several good mentors. I would say the other thing I've noticed is, at least at the time that I looked at it, there were key people in neuroscience at least, that spawned whole fields. So you could look at a sort of Vernon Mountcastle who had generations of people that came after him that really defined the field of motor neurobiology. So I think it was very clear that mentorship spawned down and created whole fields for people that were lucky enough to be in those kind of family trees.
Wow. So there was this path of really going into science. At the same time, I saw that at some point there was this, I'd say interest, I don't know if pivot's too strong of a word, but into scientific communications and supporting, scientist entrepreneurs. I'm curious, as a scientist who came in, as you said, just wanting to do science, what excited you or interested you about that path?
So it was a bit serendipitous. I had always been one of those people that read quite broadly outside of my immediate field. I was in London doing a postdoc, and at the time, pretty much everyone was doing second and third postdocs before they actually got a faculty position. And a number of people had told me, don't leave the United States because you lose that network connectivity that's going to enable you to get the job in the States going back. But I did it anyway, and I was looking around for a second postdoc, essentially, when I stumbled upon an ad for an editor of the newly formed Nature Neuroscience journal. And I thought, oh, that's interesting. They asked you to write a News and Views article that talked about a publication and sort of your perspective on why it was important. And I thought that would be a fun thing to do, honestly. So I did it as part of this what am I doing next thing. I faxed it in because that's what you did in the day, and I never heard back. So, fine, okay. I was explaining this at a Christmas party, and it turned out that one of the people in the room was a Nature editor at the actual mothership Nature, and she said, well, we've launched this journal, Nature Neuroscience, and that has taken our neurosciences editor. We're looking to replace that person at Nature. I think you should apply, right? And I'd had all these materials prepared, and so I faxed them in, and this time got a response, and the next thing I knew, I was getting offered this job. And I thought, well, who doesn't want a postdoc who has a year's experience in high-profile publishing at Nature, right? So what do I have to lose? So I actually never made a decision explicitly to leave the bench. It was more that I went to Nature and really fell in love with the opportunity to both work with colleagues that were experts in various fields, but very keen for all of us to share and be excited about what we were publishing in Nature. And at the same time, the opportunity to read, have come across my desk the hottest innovations or hottest new findings, and then be able to literally call up Nobel laureates and say, hey, would you take a look at this and tell me if it's worth publishing? So that opportunity to really learn across disciplines was super exciting. And the opportunity to help people, help science communicate better. I was so gung-ho about the idea of opening up kind of the old boys network of Nature to let new authors in, let new lifeblood in, and so that just it was a good fit for what I cared about.
Wow. Well, I'm hearing two things. One is it goes back to what you said about luck and timing. So there was a serendipity there as well, at being at this holiday party and having the right person there kind of hear your story. The second is, I think what I'm hearing from you and what I've seen speaking with other scientists is often what draws folks into this field is a deep curiosity and wanting to satiate that curiosity. And here at Nature, you almost had a bird's eye view, as you said, of just all of it was happening and being able to have direct access to some of the biggest sort of thought leaders in that field. So I can imagine that sort of, I don't know if dopamine hits the right word, but...
Don't say dopamine to a neuroscientist.
That's right. That's great. Yeah, you probably have a very good explanation for what's happening in our brain that's actually making us want to learn more information. But I can imagine that being a really satisfying place to be in.
Yeah, it was wonderful, and it was still very much a small operation. It had just, I think, been purchased by Holtzbrinck a few years before I joined, and it subsequently grew, right? There's, I don't know how many Nature titles, but back then there was Nature and just a few titles. And it was very much, we would all get in a room every day, all the biology team, and discuss what new manuscripts we received, advocate for whether we wanted to send them out for review. And we really did have to advocate, right? The ecology and evolution editor would say, why are you sending that paper out about dopamine and reward when I can be sending out a paper on a new fossil that we've just discovered in Africa? And so it was very much a great opportunity to look across science and help it.
So there are organizations and publications like Nature where, if you get published in Nature, that's a real career-making, potentially event in one's life. At the same time, there's, I hear, criticisms of the publishing kind of industry and the power that it wields, and the way in which it, some folks say, has an impact on the way in which science is done and is funded and so forth. And so there's kind of almost this other movement around open science. And there's an organization, PLOS, that you were, I believe, part of at an early stage. And when I was reading on their Wikipedia, and you can maybe fact check this, I can fact check this with you, it said, PLOS began with a pledge that from September 2001, scientists would discontinue submission of articles to journals that did not make the full text of their articles available to all, free and unfettered, either immediately or after a delay of no more than 6 months. So a real statement here in which is, these publications are awesome, but at the same time, there's a need here to serve the larger research and academic community, and we need alternatives to them. So what was going on there? And could you tell me a little bit more about why you joined PLOS?
I love that you pulled that out, because it is actually the reason I joined PLOS, because that announcement was made when I was still at Nature. And all of these 100,000 people, I think, signed this pledge saying they would not review for or author in journals that don't make their content freely available. And this was a big deal for us, because we relied on the scientific community for our to produce and create this journal. And so internally, everybody was on this kind of watch, like what's going to happen on this day. I forget what day it was. And then, the day happened, and pretty much nothing happened. I think I had 2 people write back to me and say they would not review for Nature because of this policy. Pretty much everything else was business as usual, because, as you say, or maybe, as we know, publication is the currency of scientific careers. And so it became clear that without good alternatives, scientists had no choice but to continue with the publishing system as it was, which led the folks that started PLOS as this open access movement, which were Harold Varmus, Pat Brown, and Mike Eisen, to decide to become a publisher themselves. So PLOS started out as this advocacy movement, became a publisher to provide alternatives to scientists who wanted to support the idea that research that is federally funded and paid for by the public should be freely available to the public. And so when PLOS got started, and I got a tap on the shoulder and said, hey, do you want to come and help start this thing? It was just really a no-brainer, because I thought at that point, I had become, I'd had the pleasure of being part of Nature and its access and its, the whole world of high-profile publishing, but really felt that I could make a difference in how scientific information was disseminated. So that was what brought me to the Bay Area.
Wow. So how has that mission, in your view, it's been some time since you were at PLOS, and a lot has happened in the field of scientific communications. There are organizations now like the Center for Open Science, the Chan Zuckerberg Institute. I think they're not too far from here. They've got an open science initiative. I was just reading that 2023 was the year of open science from NASA's TOPS mission, Transform to Open Science mission. So there are all of these other initiatives, some of which are pretty new and seems like pretty well funded, that are trying to maybe continue to hold the flame of maybe PLOS's original mission of really trying to have everybody share freely. I also hear from like the AI perspective as well, as we look for more data and data sets to feed these models. it's really useful to see the experiments that didn't succeed, didn't get published in Nature, right? And let's get access to that information because that's really useful training data as well. So where are we today in 2025 in this kind of open science and communication space?
There's a continuum from open data sets to open publications. Publications are an artifact of the print world that we haven't truly converted into the most useful format, right? It is something that, the PDF, the HTML, it's a static snapshot in time of a research agenda. So I think PLOS had a more concrete mission at the time that we started, which was really around the internet's here. It no longer costs money to print paper journals and send them around. Why are we charging these crazy subscription fees? Why is it not freely available if the internet allows it to be freely available? And what's exciting to me now is that pretty much that transformation is complete. More or less, every journal out there has some open access option, and the conversations now around open access subscriptions and publishing is a very different set of issues around economics and so on, which are important. But what's exciting to me now is that with AI, as you mentioned, we suddenly have the capability to mine that literature in a way that we dreamed about 20 years ago. We said, if machines could read this stuff, imagine what they could do. And machines can now read this stuff. So I call that a win, and it's really an exciting time for me in terms of what can happen with the scientific literature now that it's open access. On the other side, there is all of the open science world about how we do science, how we share it before the level of thinking about publication. You could imagine a world in which we had electronic lab notebooks that sort of synthesize and communicate with all of our research equipment, and then produce data that then is converted into a paper if that's what you want to do. The data is deposited in the relevant data sets, and you can imagine this continuum from sort of open science to open publishing. But there are a lot of incentive structures that need to be realigned to really make that happen. So you have to think, and people are thinking about how do you give credit to folks that are producing data that maybe you don't need to have a publication sitting around. But right now, or how do you give credit to folks that annotate and reuse data and contribute to the post-publication dialogue of the worthiness of certain fields or certain research papers. All of that hinges on being able to properly credit scientists for putting in that effort. Because right now they're all just overworked and trying to keep their careers going, especially in an increasingly fraught funding landscape.
Wow. I mean, I think what you're talking about in terms of attributing credit to scientists whose data might be used for a model, I mean, that feels very analogous to the larger conversation we're having about large language models and the data they get trained on from artists and YouTube creators and so forth, and the value that that's then captured by those organizations but not kind of shared. Clearly from a scientific research perspective, it's not just about money, right? It's about the credibility and the portfolio that you have that you can then that opens then doors for new career opportunities and so forth.
Yeah, absolutely. They're very analogous conversations. So I'll leave it at that.
Okay. All right. So we talked about again, as we're looking at the larger picture of how do we help organizations, especially in the scientists and scientist founders, get their ideas from out of the lab into the world. There's a piece of the conversation around for those scientists, especially maybe when they're still in academia and so forth, how can we get them to be able to share the research that they're doing in various ways, get credit for that research, to open doors from them, maybe to get more credibility with investors and so forth. There's also, you mentioned at the end, funding and sort of the money part of the conversation. And there's various models there too around kind of injecting money into new startups, into ventures. At Breakout Ventures and Google X, you were deeply involved in translating deep tech ideas into real-world products. I want to dig in more into kind of their points of view of how to help organizations sort of go from 0 to 100. But maybe before I do, could you maybe just share a bit more for folks who don't know much about those organizations, like what their founding goals were in this space?
Yeah, so we started, I want to make a distinction between Breakout Ventures and Breakout Labs. Breakout Labs was a program that we started at the Thiel Foundation in 2011 or so. And the idea there was really how to support scientists with radical breakthroughs that had the potential to have huge impact on society, how to get them off the ground in a commercial direction. And so it was sort of this idea that the Silicon Valley of old, building things in their garage, maybe you can do biotech in your garage, but who's going to support that? And this was a time really when Silicon Valley had pulled back from its origins in what we now call deep tech to the kind of .com food delivery app world, right? So there was actually the term deep tech, the term frontier tech, all of that didn't exist. And we set out to put philanthropy into the mix to say, look, if we as a society are supporting science in the name of public good, and we expect the fruits of that to come into the commercial world, or even the non-commercial world, but to come into society, who's supporting that transition? So we made that case that mission-driven dollars are needed to support that effort. And we put out a call for scientists across the spectrum who had what they thought of as a breakthrough and a hypothesis for its commercialization. Our original thesis was we put in some capital and we would help them to de-risk. And very quickly we discovered, surprise, surprise, they needed a lot more than money. They needed, support and networks and business experience and mentorship and all of that. So that became quite a focus of what we did through Breakout Labs. We eventually invested in, supported through convertible grants, 50 deep technology companies from we had a company, one of the first lab-grown meat companies, Modern Meadow, which was how that started out. We had antimatter space propulsion, biofabrication of leather, which is what Modern Meadow ended up doing for a while. We had therapeutics, you name it. So along that process, we found that a subset of those companies were going on to raise venture capital. And so we launched Breakout Ventures to sit beside Breakout Labs to invest in those companies that were growing out of Breakout Labs. Today, we shut down Breakout Labs in the Thiel Foundation in 2021. Breakout Ventures continues as a venture fund that invests in deep tech.
I'm curious, as you reflect back on the organization, and there are other folks now, the deep tech kind of investment space has grown. What do you think, what's one thing that you think, you really got right in that model that, folks who are interested in maybe setting up similar ventures should continue to emulate?
I think building the community for those founders and bringing them together, and it's a very lonely business doing entrepreneurship, particularly deep tech entrepreneurship, because it takes so long, right, to get anywhere. And I think now you see at Stanford or MIT, right, there are those communities, there is that zeitgeist and that pulling together that this is a worthy thing to do. But in other parts of the country, that hasn't been there. So we opened up our doors to companies, founders across the country, and brought them together and gave them that sort of sense of community. And they're still in touch with each other. It's an amazing community. So I think we really got that part right. And along with that, we had created an ambassador network that was essentially undergrads at research, or grad students at research universities that were interested in entrepreneurship. And by becoming Breakout Labs ambassadors, they were able to go to various events in their local communities, talk to entrepreneurs, the goal being to attract them to apply to our program. So I felt like the community piece was really important. And the bringing in a network of potential buyers, if you like, whether it's corporates or other investors, that could really help them to understand those audiences and what they were trying to build and what other folks value beyond what they value. Because technical founders tend to really focus on the technology and the advancing and perfecting of that technology without understanding that actually no one outside of them really cares if it's perfect if it doesn't solve a problem, right?
So community, and also it sounds like bringing them early in front of potential customers and partners with them.
Exactly.
That could sort of sanity check and reality check what they're building. Were there any, I imagine, well, in deep tech, because it does take so long, or especially because it does take so long, people are very, I would say cautious about IP. How did you navigate, that when you're trying to bring folks in front of partners?
By teaching them to be less cautious about IP. I mean, honestly, at the stage where we were funding a lot of these companies, there was probably some university IP that they were licensing, but as these companies evolve, that the intellectual property portfolio changes quite a bit, and these things are so hard that no one is going to steal your idea and go off and do it. Maybe once, I don't know, but that is not the challenge. The challenge is really for you to convince others that there's value there. And at the stage of life that these companies were in, no one's really going to see that value until they get much further along in their development. So I think one of the earliest and most compelling things that we were trying to teach our entrepreneurs is to be less paranoid. And there are things you want to secure, but talking to a potential corporate partner about your technology, there's just no way they're going to steal it at that phase of life and go do it. They are looking for mature technologies. That's part of the broken pipeline between academia and big corporates, which startups fulfill, is that they take that technology readiness level to a point where corporates are willing to jump in and partner or adopt.
So on the flip side of that equation, I was at a deep tech conference last year, and there was somebody who was from a mining company and talking about how they partner with startups. And he was saying, we get so many requests for folks to try to test out some new technology, on our site. But at the same time, and then he gave some incredible figures of how much earth that they were moving and just how disruptive it is to try to cater to any one specific startup that might be disrupting their finely tuned logistics. And so he said, we get requests, we have more requests than we know what to deal with, and frankly, it's really hard for us to figure out how to partner with these startups. So how did you solve for the other part of that equation, where you convinced these busy executives who are maybe managing portfolios with billions of dollars of revenue to pay attention and spend time with these startups?
Well, a lot of the corporates did, and I think still do, have these sort of chief innovation officers or scouts or people that go out into the world, and those are the people that we typically interact with. But I think you're touching on a very important point, which is that a lot of startups think they understand the problem that they're solving, but actually don't. And that journey of iteration, of going and talking to the corporates and realizing exactly what challenges those corporates are facing, exactly how their infrastructure is set up and where you can slot in, does take time for technical founders that don't come out of those industries. I mean, it's really exciting when you get a technical founder that comes out of that industry and says, look, I know exactly how this supply chain is set up, I know exactly how this process happens, and I know where there's pain points and where we can solve them. But typically, if you're getting like a PhD out of a university lab and they say, I have a new, chemistry to build whatever it is, industrializing that and learning what that takes and what will be adopted and what won't is one of the key learning processes that a lot of deep tech founders have to go through. And it is slow because, as you say, the folks that are actually running the plants are not the people that are out in the world engaging with the startups, and they don't want to share necessarily their secret pain points until you get relatively deep into these relationships.
Well, that makes me then appreciate, when I talk to folks who are, VCs themselves, how much, experience matters or gets them excited. And I think it speaks to that point, right, where it also helps them, if they've already sort of iterated before they've even gotten to the stage of being a startup founder, they've learned a lot of those lessons and, can maybe get to value more quickly.
Absolutely.
Okay, so Breakout Labs, Breakout Ventures was one sort of approach and model. There's also this very large company called Google, which had its own ideas for how to really kind of support and develop and nurture, it seems like, deep tech ideas. Maybe not external ventures, but sort of almost like in a venture studio model, it seems like. Could you share more about sort of what you had learned of what was Google X's founding vision? And then I'm curious to dig more into your experience there.
Yeah, I think my joining X, so we shut down Breakout Labs in 2021, and I didn't want to be just a venture capitalist, which, not that there's anything wrong with that, and it's very important, but I would say that one of the things that struck me about our Breakout Labs companies when I looked back then was there was almost this bimodal distribution of companies that were, performing at a venture level, doubling their value every 24 months, meeting sort of classic comparables, et cetera, and then a set that were much more slow growing and organic and really taking quite a bit longer to reach that kind of inflection point where they really could attract big dollars and had big targets that were specifiable. So I have been interested in that second set almost more than the first set because I do think there's a lot of technology and a lot of that can solve a lot of problems and open up important opportunities that can't go at that venture timeline quickly enough to stay alive, basically. And so thinking about corporate innovation, it occurred to me, or it made me wonder, could that be another model, particularly something like Google X, where you could have different kinds of milestones that you were trying to achieve that were not on a venture timeline, but that were still proving out the importance of what you were doing and the potential of what you were doing. And you would have essentially more patient capital. More patient capital on the one hand, and also a kind of corporate lens that would perhaps give you some intelligence around the actual processes that big corporations go through to make decisions and implement technologies. So yeah, that's what drew me to X. And I'd seen Waymo, Wing, I think Loon, the internet balloon, was still alive at that point. And of course, Google Glass and the glass holes were around back in the day. And yeah, it just seemed like a candy store, really, right? An opportunity to really. So I jumped on it and jumped in and had the wonderful opportunity to build a team of folks that were trying to initiate new moonshots. So the idea was, let's think of let's scour the landscape for big problems that match technology solutions that somehow we would have a tailwind at X to be able to solve. And let's go and do some early experiments, figure out if there's there, and then hopefully get funding to build some of those projects into the next Waymo.
Wow. I love that term, patient capital. I'm curious, when Google was looking at, or Google X was looking at these different opportunities where you said there were some tailwinds that we could support with, what was the kind of the North Star? Was it, hey, we want to diversify our revenue streams and potentially we could go into these new business areas? Was it a personal kind of mission-driven impetus where it's like, hey, we want to tackle some issues in health or sustainability or climate change? Can you share more about sort of,
So one of the founding principles of X comes from Clay Christensen's disruptive innovation, right? This idea that big corporations don't see the disruption because they're focused on, supporting and building the framework they've already created. And so I think part of the founding of the Moonshot Factory was really around this idea of doing things that the main Google would never do. And so really that was blue sky. And the idea became that a moonshot would sit beside Google, essentially, in Alphabet's portfolio of big bets, and that eventually one might come to be the new dominant player. And so it was this idea that you would have an internal skunkworks innovation lab that was doing things that were outside the core business. Having said that, folks came into X because typically they cared about a set of problems, whether it's climate. Increasingly, it became climate and sustainability. And so there was a strong emphasis in the portfolio on those types of solutions. And that was also an interesting place from the perspective of the promises that Google had made around doing green technologies or supporting their data centers with green electricity, that kind of thing. So there was an emphasis from Alphabet to do good and to make best efforts to align their business practices with green and sustainable practices. That meant that the kinds of technologies we were spinning up at X could eventually possibly be sold to Google. For example, there's a company called 280 Earth that was a Google X spin-out that is doing carbon capture. And I believe, although maybe I shouldn't be quoted on this, that Alphabet is one of their early adopters.
Okay. So maybe reflecting on both of those experiences.
Yeah.
So you have a really great TED-Med talk.
That's old.
Yeah. And seemingly very relevant, where you talk about this valley of death between basic research and essentially venture fundable startups. Just literally earlier this week, I was chatting with somebody who works at this really interesting kind of well-funded nonprofit that does a lot of kind of life science R&D. And the way he used kind of picture that he painted, he said, academia is good for going from like 0 to 1 if you have an initial idea and you're trying to make it more concrete. He goes, the private sector, whether it's industry or startups, are great from like 10 to 100, like taking something that's like relatively ready-baked and really, scaling it up. But the kind of 1 to 10, part is really challenging. And finding, patient capital and the right resources to be able to take an idea from out of the lab and bring it into a world that it can be scaled is really challenging. So as we look at that valley of death that you had described, is Breakout Labs the solution? Is it more Google X's spun out by other large organizations? What's your kind of takeaway from those experiences?
I do think that the startup is where all the incentives align around hardening technology breakthroughs or scientific breakthroughs into technologies that can be commercialized. I say that because academia has its incentives tied up in novelty, and it's in nobody's, no graduate student's interest to do the next 27 experiments that confirm the thing that we have already published the Nature paper around, right? So sadly, or maybe not sadly, I don't know, the incentives are just not there to get a scientific breakthrough to the point where it is really something that can be the basis of a commercial enterprise. At the same time, commercial R&D has pulled back quite a bit from being able to take something from academia and really do that hardening process themselves. And so startups really are a place where all of that alignment is there. And yes, we need as many ways to support those startups as we can. Happily now there are more and more of these incubators and accelerators and philanthropic efforts, particularly around climate and sustainability, that are supporting these kinds of founders to try and make a difference. Yeah, I think it's the startup.
Mm-hmm. So doubling down on the startup ecosystem. We are right now recording in a co-working space that is focused on sustainability and supporting kind of deep tech sustainable startups. There was an event here the other day where they were talking about this new political administration and their views on sustainability, right? We heard drill baby drill in recent speeches. So I guess for deep tech especially, which tends to be kind of more regulated spaces, like what advice would you give to folks who have an idea maybe in sustainability and, who knows what the next administration, we'll think about that and so on and so forth, where it seems like we're sort of, seesawing between different levels of government support or investment in these areas. What advice would you give those deep tech founders about what to make or how to factor those kinds of discussions and political wins in their own journey as a deep tech founder?
I think it depends on the sort of age and stage of the company, but in most circumstances, a startup founder has to be ready for a long game, the marathon, not the sprint, and has to passionately believe in the thing that they are building. So it reminds me of sort of my earlier comment around luck and timing and so on in research. You can't play too much to that, right? Maybe there's a certain type of personality that can sort of take in all the market forces and say, okay, now is the time to start an oil drilling company or whatever it might be, right? But if it's early enough, you have to find the people and the institutions and the organizations that align with your vision. And you go out and you try and find those people as hard as you can, and if you can't make it work, then you do something else. But I don't think you can be overly indexing on the current support or lack of support, for example, from federal funding. You can maybe change your strategy somewhat. I think federal funding has been absolutely critical and brilliant for this very early startup, the transition between academia and startup. That non-dilutive capital has been absolutely instrumental in so many of the companies that we see today in the deep tech landscape. If that dried up, I suppose it would change quite a lot what you could spin out. On the flip side, maybe philanthropy comes along and picks up some of that. I don't know. But I don't think you can be overly prescriptive, otherwise you lose the motivation and you're not in it for the long run.
Well, I would say, I guess one of the bright sort of maybe silver linings that we have here is there is a lot of really interesting work and kind of recent breakthroughs that are maybe coming from some unlikely places. So there was the Nobel Prize in Chemistry, which was given to a team that included DeepMind, Demis and their AlphaFold work. From the DOE over the last few years, they have this really interesting AI for Science initiative. I believe Rick Stevens at Argonne is sort of leading that. They're doing really cool workshops and kind of initiatives that span multiple labs to try to accelerate initiatives around different types of scientific discovery that are supported by machine learning. The deep tech community, at least in San Francisco, over the last year, I've seen has really started to come up, and there's really large events now, and kind of an interesting infusion, it seems like, of interest, maybe also of capital. So, do you think have any new enabling factors emerged over the last year or two that have, you think, supported this kind of it seems like new interest in deep tech, or is this just maybe sort of a consequence of the AI hype that we're seeing and kind of bleeding into deep tech? What do you make of what's been happening recently here?
I don't know that I've seen a radical shift. It seems to me that this has been building for a while, certainly before the large language model excitement. I think that there was a swing back towards, one of the reasons we actually shut down Breakout Labs was that venture capital was going earlier and earlier and basically playing in this place where we were sort of a mission-driven, the balance between philanthropic and venture capital was shifting, right? So I think that's been happening for a while, partly because computational power, simulation, all of that has meant that you can iteate faster, that you can do experiments in silico that then feed into your real pipeline. That means that you can get more for your buck, and that's brought venture capital in earlier and earlier. So I think all of that is there and has continued to grow. I think there's a new generation of scientists who are very focused on the problems that are affecting the planet, and I think are driven to find solutions in a way that maybe my generation wasn't. And I think that's very exciting and has driven part of that engine of startups. Certainly in the last couple of years, the large language models have added a large amount of anticipation and excitement to how we can interface with science more effectively. And I think that's, the jury's still out on how much that technology will influence scientific discovery, but it's a very exciting time, and I see why there's lots of investment there.
Well, you talked about a new generation of leaders. You sit on a number of boards. One of them is E11. They had recently announced a new method to reveal the complete wiring diagrams of mammalian brains. As a neuroscientist, I'm curious to get your perspective on why is their work important, and what are some cool things that we should be looking out for in your field?
Well, first of all, I want to give a shout out to E11 as a focused research organization, which I don't think is a thing we've touched on, but I think is a very interesting model for the translation of scientific discovery, potentially into commercial applications, but also potentially into technologies that feed into the scientific ecosystem and really allow a scaling of technology tools to help scientists make their own discoveries across the world. So E11 is one of those focused research organizations that's a nonprofit that was philanthropically supported, and spun out of, I think, Ed Boyden's lab around this idea of expansion microscopy, which is a really surprising and interesting technology that allows you to infuse tissue with a gel that literally expands it and makes what is normally visible only through an electron microscope actually visible in a light microscope. So it's super cool technology, and essentially E11 was set up to really make that process something that any lab could just access and use, and really therefore vastly scale up the ability of neuroscientists to understand the internal connectivity and wiring diagrams of their system of interest. So I think the potential's enormous, and they've made real progress in the last couple of years, as you have read. And the potential for basic understanding of the brain, because we really still don't understand how, we don't understand the sophisticated wiring diagrams and how that relates to molecular information, how that changes during disease states. So all of that suddenly starts to open up. So I think it could be very, very transformative for a lot of neuroscientific questions.
Well, thank you for bringing up focused research organizations. So just a couple days ago, I went to a happy hour and ran into Sam Rodriguez, who's the co-founder of Future House, which is one of these focused research organizations. founded by, or I guess funded by Schmidt Futures, which is kind of, again, the Google connection. I think Eric Schmidt's sort of fund to accelerate scientific discovery. FROs, I saw, are defined as focused on solving well-defined challenges to produce public goods that are neither profitable nor publishable. So again, I think we're pointing to this sort of like, maybe, I don't know if valley of death is the right word, but sort of resources that don't have an obvious funding model behind them, but that are going to be really important for getting the whole field to level up. So, a lot of the talk about innovation in the tech space and deep tech space is around the technology. But again, this is another example of innovating on the model that gets the technology out of the lab and into the world, in the same way that you saw at Google X and at Thiel Lab. So.
Well, I was just going to say, when I talked about the startup as being that engine, I didn't just mean the for-profit startup, right? You can think about a whole nonprofit startup world, like Conservation X Labs, I believe, has supported a lot of nonprofit startups, and I think that's equally, has the potential for equal impact and to address problems that maybe are not commercializable in the way that investors would support.
Interesting. Well, given your deep experience in publishing and supporting scientist founders, where are you excited to be investing your time and energy in next?
Well, hot off the presses today, I just signed an agreement to be an entrepreneur in residence at the Engine, which is a spin out of MIT, our alma mater, which supports what they call tough tech, as opposed to deep tech and frontier tech, but pretty much scientists trying to make the world a better place. And they originally started out coupled with the Engine Ventures, so they were a venture fund and a incubator accelerator. And as is often the case, it's very hard to make that two very different kinds of entities coexist successfully. And so from what I know, they are now separate. And I'm working with the Engine Accelerator Incubator to figure out new programming and new ways to support scientists who are thinking about becoming entrepreneurs and then who have become entrepreneurs and are looking for further funding and support.
Wow, congratulations.
Thank you. I'm super excited about that. It's a great team, and they already have what's called a blueprint program that is like a 6-week course to help scientists make that go, no-go decision to really understand what entrepreneurship entails, what being a CEO of a science startup is all about. It's not actually about being in the lab, which, this comes to a surprise as many. So they already have that as one means of community building and showing support for budding scientists. And then, of course, they have a physical space where companies can come and incubate and grow. So that's one thing. And then kind of on the other side of the spectrum, I have been working with an organization called Annual Reviews, which is a nonprofit based here in the Bay Area. They're almost 90 years old, maybe a little older than that, and came from a biochemist at Stanford who in the 1930s discovered that science was moving really fast and there were so many publications that it was very hard to keep up with and synthesize that knowledge. And so I believe Annual Reviews of Biochemistry came from that, and the Annual Reviews series is now 51 titles across diverse research fields and has always been and is quite a reputable source of solid synthesized scientific findings written by key opinion leaders in the field. So Annual Reviews has a real history and understanding of how to create and how to synthesize scientific knowledge and disseminate it to scientists. We are now looking at other audiences for that content and ability to synthesize information. So you can easily imagine that, or we know that scientific information plays an important role in policy, in all kinds of, in education. All of that are there ways that Annual Reviews can expand our mission to include more than just scientists, but also society that can benefit from scientific information, from scientific knowledge.
Yeah. Wow. So, already in the 1930s, we were overwhelmed
Exactly.
with the
No, I
amount of
was
research.
really struck when I saw that. I was like, wow, okay, this is not a new problem.
Yeah. In fact, I was at one event I attended last year. There was somebody from the Allen Institute who was working in the connectomics space, and somebody was asking him, like, what are the kind of largest challenges of moving your work forward? And he said, as we learn more about every field of science and become increasingly specialized, just being able to communicate what we're finding and doing to another person is becoming increasingly difficult. He said, if you want access to one of our data sets, we need to put you on the phone with a PhD for a couple hours, right? Yeah. Just to walk you through how to even make sense of it, much less like do work with it. So this work of synthesis, I imagine, is only going to become more important.
I think that's right. We are in an age of data overload, and we are kind of returning to who do we trust for information. It's, when you think about how journals actually started, they started from this community idea, this who do we trust, and how do we share information. Peer review is all about trusting and creating a community of folks that we believe are knowledgeable about a field and we can learn from. And so I think we are returning quite a lot to the idea of the importance of communities in helping us filter and synthesize and understand information.
Well, one question I like to ask on every one of these episodes is, we've got an audience of folks with a bunch of resources, right? Whether it's their talent, it's their time, it's their access. As you look to your next chapter and your next, two really great opportunities, what's one way in which our audience can be helpful to you?
Well, I think there's sort of the two strands of my work. I am now actively looking for potential partners to work with annual reviews on new products, for want of a better word, but new ways in which our content can be, or our expertise can be leveraged to bring science to important problems in society. And then on the flip side with the engine, now that the accelerator is fully separate from the venture fund, we are really building out a community of investors and mentors for the companies at the engine. And so I will be working on that actively and encourage folks to take an interest in the companies that we are supporting there.
Awesome. All right. Investors, mentors, partners, take note.
Uh-huh.
If folks want to get in touch with you, is it looking you up on LinkedIn? What's the best method?
LinkedIn is a good idea.
That works?
Yeah.
Okay, cool. Well, Hemai, as somebody who has personally walked the path from the bench into publication, into supporting deep tech startups, I'm just so grateful to be able to have mined some of the deep experiences that you've had, share it with the next generation of entrepreneurs. So thank you so much for your time.
Thank you for having me. It's been a lot of fun.